Hello and welcome to this video on ionic naming. So the first thing we want to talk about is how to name our cations. And in order to do that, we are going to talk about single metal or single ion metals. And so cations are always metals with the exception of if we have a polyatomic ion. And so they only have one possible charge. And we use the actual name of the metal. There's nothing different that we need to do. So for example, if we had potassium as an ion, K+, the name for potassium in its ion form is still potassium. Okay. Now, if we have what we would call multivalent elements or metals that can form more than one ion, then we have to use a little bit of a different system in that we have to designate what the charge on the ion is using Roman numerals. And so in this case, a good example for that is copper. So we can have copper 1, which is Cu+, and when we write that out, we write it out as copper, and in parentheses, a capital I. And then if we have copper 2, 2+ charge, then we write that out as copper 2. Okay? And so two capital I's basically put together. Now, that is something that we can do with either, if it's a sans serif, you might not see those tails going on the top there, and so that's something that we can take a look at, especially when we get to something like our periodic table of ions. And so what I want to show you is these examples. So potassium, this is really handy, is here, and the name for the potassium ion is potassium, and we see that on the periodic table of ions, and this is something you can refer to at any time to help you with this naming, because we want to get used to the names of these particular substances so we can communicate. And then we see the example of copper here in the transition metals, and we see copper 1 and copper 2, and you see that those are just they're sans serif. They don't have those tails on the letters. Our polyatomic ions all have their own names, and then we're going to take a look at the fact that all of those negatively charged ions end in ide, IDE. And so let's just kind of make sure we solidify those Roman numerals. So for 1, it's going to be a capital I. For 2, okay, then 3. 4 is an I and a V, capitals again. And then 5 is a V. And so that is just counting from 1 to 5 using Roman numerals. So remember, it's a capital I or a capital V. Okay, so whatever you're doing with those, even if they don't have the serif on them, as you're taking quizzes and entering those values in, just kind of keep that in mind. All right, so now let's talk about those anion names. All anions only have one possible charge value, and you use the root of that element name and then an ide at the end. And so, for example, we could have something like nitrogen, which is a 3- charge when it becomes an ion, and that's going to be nitride. Okay, and so notice the ide is at the end of it, and then the root part of it, the root of that is the nitr. Okay, or for example, we could have oxygen as a 2- charge, and that would be oxide. Okay, again, the ox is at the beginning and the ide is at the end, and luckily for us, in getting used to those root names, you can also refer back to your polyatomic ion table, or excuse me, your periodic table of ions. Polyatomic ion names are on that as well, and so we have these polyatomic ion names. They actually each have their own unique name, and there are some rules for the oxyanions. Those are the polyatomic ions that are the same except for they have different numbers of oxygens. Okay. There are some rules for these. I don't go over them in class. You have the chart to refer to. Make sure you're pulling the correct one. So here's some examples of these. We could have something like OH minus, okay, and if we look that up on the list, that is hydroxide. Notice it's still a negative ion, and so sometimes we'll still see the ion there. We could have something like NH4 plus. 4 is little, the plus is the charge, the plus 1, and that is ammonium. Or maybe we could have something like NO3 minus. 3 is little, the minus 1 is the charge up top, and that is going to be nitrate. And so these are on that polyatomic, periodic table of ions in that polyatomic ion area. Or you can find lists of them different places to start to learn those names and what their charges are. And hopefully we get used to some of these over time and using them. So that is how we name the individual ions. How do we put these together when we're talking about an ionic compound? And so there's a two-name system. We have a first name and a last name for these compounds, and think of it as the cation and the anion. The cation is the first name and the anion is the last name. Always cation first, then anion, no matter what. That is the standard way in which we write these. And so let's actually give some examples. So I'm going to go ahead and talk about my charges again. So say we have something like magnesium, and say we have a 2+ charge there, and say we have phosphorus. Okay, phosphorus is a 3- charge. So remember that crisscross method that we talked about. We're going to move the 2 down here, and we're going to move the 3 down here to get our formula. So I'm going to kind of model that again. And then we get Mg3P2. Now, it doesn't matter how many we have of each one of these when it comes to ionic naming. If we see a magnesium and we see a phosphorus, we have a metal and a non-metal together, we know that the name of this is going to be magnesium phosphide. So again, I'm just modeling how we come up with the formulas for these once again. Let's go ahead and take a look at one that's going to use iron. Okay, so let's do iron as a 3+ charge, and oxygen, oxide, right? As soon as it's an ion, it's oxide, as a 2- charge. Again, use our crisscross method, and we get Fe2O3. Now, with this iron, the iron is the 3+ charge. It could be a 3+ or a 2+ charge. Okay, and so in this case, this would be iron 3 oxide. Now, what if I had the opposite of that? What if I had Fe2+ and iron 2 and oxide together? Well, then my formula would be FeO, because they're in a 1-to-1 ratio of magnitude, right? So even if I did Fe2O2, I would have to simplify that, and it would be FeO. And in this case, this is iron 2 oxide. So there's an example of how we could have those two different charges with the same anion. All right, let's go ahead and do a polyatomic ion example as well. So this is one that we have. So say we have NH4+, which is ammonium, and we have NO3-. Now, the charge values, it's a 1+ and a 1-. So when we crisscross those, we still have a 1-to-1 ratio. And so our formula is going to be NH4 NO3, and this is ammonium nitrate. So ammonium nitrate. Okay, NO3 with a -1 charge is nitrate on that list. Okay, let's try one more, and I'm trying to think of what I want to do. Let's do sodium sulfate. Okay, and so you got to be careful here. So we're going to do sodium, which is a 1, and sulfate, which is an SO4 2-. Okay, so when we do this, the 2 is what the charge is on this one. So when we crisscross, so I should do one more for you, but we'll see. So when we crisscross, it's Na2SO4, and this is sodium. Sulfate. All right, let's do one more because I want you to see one that would have parentheses for the formula. So let's do one where we have magnesium hydroxide. Okay, so we're going to pull magnesium again. I like magnesium. Okay, magnesium and hydroxide. Now, when we do this, we're going to do our crisscross method again, and we're going to have Mg, but we actually are going to put the hydroxide in parentheses because there are 2 of that entire hydroxide. Okay, and then of course we call it magnesium hydroxide. IDE. Oops, I ran out of room there. Let me put it down below. Hydroxide. I hope those examples are helpful for you, and we'll continue to work on these in class.